right. Good morning, everybody. So, as I had mentioned yesterday, I am not there today. However, we will be following our usual test procedure, which is just kind of taking a practice test where the questions are going to look really, really, really similar. Hint, hint, wink, wink, nudge, nudge. And so, hopefully, by now, you've had some time to work on this actual practice test. Um, there are only 6 problems. Again, this is built for us to really just make sure that we've got these rules down and to be hopefully like a solid grade in the grade book, to be honest. And so let's take a look at number 1. We simply want to find the derivative of the function f of x is equal to 2x to the fourth plus 9x plus 3. Now, as soon as I see this polynomial, my brain is already firing off power rule because, I mean, that's really all we need to use for polynomials. So like quadratics, trinomials, anything else where it's simply just terms with addition, power rule is our go-to, and it's actually super convenient. And so let's remind ourselves really quick that power rule is going to be when we have or want the derivative, so d dx, of something that looks like ax to the n. Now, I know we didn't really include a in our notes. If you want to, you can. All it's really saying is that there might be something there might not be something there as a coefficient. And so that derivative is simply going to be n times ax to the n minus 1 power. So again, we just take this power, bring it down, multiply it by whatever may or may not be there, and then reduce the power by 1. And so if we're taking a look at this, f prime of x should just be, well, 4 times 2 is going to be 8x to the, well, now the new power is the old 1 minus 1, so 4 minus 1 is 3, so 8x cubed plus, the power here is 1, right? We don't really talk about the fact that that's 1, but it is 1. And so we take that 1, multiply it by the 9, which means we're going to have 9 times x. And now if we reduce 1 by 1, 1 minus 1, well, it's 0. Well, remember that anything to the 0 is actually just 1. And so what this becomes, after a little bit of simplification, is going to be 8x cubed plus 9, which if we take a look, matches a. There are a lot of answers in here that are made to look correct. And so tomorrow, when we actually take our test, be really careful of distractor answers. All right, let's take a look at number 2. Now, I am looking to find the derivative of g of x is equal to 3x cubed plus 8 all to the 5th power. Now, taking a look at this, there's actually 2 functions happening here. There are 2 functions, and specifically this is composition. And so as we've talked about yesterday, actually, composition is when we need to use chain rule. When we see composition, we need to think chain rule. And so, again, reminding ourselves that chain rule, that d dx of f of g of x, well, that is when we are going to take f prime of g of x times g prime of x. Now, the less mathy definitions of, or I guess the less mathy way of saying this, right, is simply that we take the derivative of the outside function with the inside function staying the same, and then we multiply all of it by the derivative of the inside function. And so taking a look at this, the inside function, or like our f of x, is going to be something to the 5th. Now, it might be x to the 5th. If you want to think of it as x to the 5th, go for it. I'm going to leave it as like nothing to the 5th, or just some quantity raised to the 5th, because it's a little bit easier to see the actual power rule being applied. Because what I'm going to do, I mean, is exactly that. I'm going to use the power rule. I have something just raised to a power. And so f prime of x is simply going to be 5, again, times whatever was originally there, that thing, that quantity, raised to the 4th power. And so, let me make sure that looks like a 4. There we go. And so that's f prime of x. And so now let's take a look at g of x. Well, g of x is going to be 3x cubed plus 8. And so g prime of x, again, just using the power rule, right? We have a binomial, which means power rule it is, 9x. And then remember that any constants become 0, so I'm just looking at 9x squared. And so if we use our sort of template here, what I'm going to have is f prime of g of x. And so g prime of x, I guess overall g prime, I know I accidentally reused g, that's okay, is going to be 5 times the original inside, or I guess with the original inside, 3x cubed plus 8, all raised to the 4th power. So again, that outside with this inside, but now I have to multiply it by the derivative of the inside, which is this right here. And so we're going to clean this up slightly, because if you look as this is right now, it really doesn't match any of our answer choices. And so a few of our questions tomorrow are going to require us to clean it up a little bit. I know that generally when we talk about quotient rule, that one is normally a little bit easier to just kind of leave as is, but product and chain we definitely want to try and clean up. And so I'm just going to take this one step and bring this piece right here just out front of here. And so 9 times 5, that's going to be 45. Then x squared times 3x cubed plus 8 all to the 4th. This piece right here, please do not try and expand that out. I use the phrase clean it up because we want to make sure it looks nice and everything's kind of neat and together. If we were to expand this, it's going to become much messier, much quicker. And so if we look now, well, hey, look, this is going to match right here. All right, let's take a look at number 3. Now, given that f of x is equal to 5e to the x plus sine of x, then f prime is, and so on this question, we're actually testing our knowledge of those special derivatives. And so if you have your cheat sheet, which I hope you do, this question is hopefully going to look pretty easy. And so f prime of x is simply going to be, well, the really, really nice thing about e to the x is that when we take the derivative, that term pretty much doesn't change. And so that derivative is actually going to stay 5e to the x. And then plus sine, well, the derivative of sine is cosine, so we're going to have plus cosine of x. And so again, let's take a look, see what matches, and here we are. And so once again, a lot of distractor answers in here. If you got rid of the 5, you're going to see that all of a sudden maybe we had b. If you used the number e for some possible reason, maybe you thought it kicked out an e, you might be looking at d. Again, be really careful about what you look at tomorrow, because again, those answers are made to be tricky. Because A, there's only 6 of them, and B, the actual math itself is fairly basic. All right, let's take a look at 4. Now, 4, again, first thing I do, as we talked about yesterday, that when I'm looking at derivatives, I need to figure out how many functions I have. That's like really step 1. And then beyond that, we have 2 branches. If it's really one function, then we're looking at using some sort of power rule. If it's 2 functions, we need to figure out what operation is happening between these 2. Now, I see this fraction bar, and so I know that it's going to be division, because a fraction bar is a literal divided by symbol. And so I know that I have 2x plus 3 divided by 3x plus 2. And so I know I'm going to be using the quotient rule. And so the quotient rule is sort of the most sticky, where we can get in the most trouble. And so let's remind ourselves that the quotient rule is going to be d dx of u of x over v of x. And remember, unlike the product rule, these are in really specific spots. These are in super, super specific spots, so I can't have these just be whatever I want. And so this is going to be equal to v of x u prime of x minus u of x v prime of x all over v of x squared. And so again, this is sort of like the biggest, potentially messiest one, just because there's a lot of moving parts going on in here. And so as we do with product rule and as we even did with chain rule, I need to be just really specific about what is what here. And so I'm going to list out, okay, u of x, that's my numerator. So that's going to be 2x plus 3, which means that u prime of x, just applying my power rule to this, is just 2. That 3 is going to go to 0, and when it's just an x to the first power, the derivative is just the coefficient, right? If we think about this as slope, it's really the slope of this line, which is just 2, right? It's even y equals mx plus b. And so I'm going to do the same thing with v. V of x is going to be equal to 3x plus 2, which means that v prime of x is going to be equal to 3. Again, just that simple constant. And so now, again, use our template and put it in our puzzle pieces. We have y prime is going to be equal to v of x, 3x plus 2, times u prime, which is 2, minus u of x, 2x plus 3, times v prime of x, which is 3, all over v squared, which is 3x plus 2 squared. Now, before I clean this up, I'm going to have to, because if we look at our answer choices, they're not as expanded as this. And so let's remember that process of elimination is a super powerful tool. And so already I'm crossing off E. I'm getting rid of option E. I don't need it. It's clearly not correct. And so y prime is going to be equal to, and now the reason I can cross E off with such certainty is because this denominator has to stay like this. I'm not going to want to square this out. I'm not going to want to do anything. It's got to stay like this. And so simply having just a 3 in our denominator, probably not a great chance. And so we're just going to continue through, clean this up. We're going to have 2, which we're going to distribute in, and this 3 we're going to distribute in. And so we're going to have 6x plus 4 minus parentheses. It's really important that we keep these parentheses. 6x plus 9. Again, all over 3x plus 2 squared. And the reason that we need to keep these parentheses is because I now have to distribute this negative. And so it's going to equal 6x plus 4 minus 6x plus, there we go, minus 9. See, even with our annotations, you need to be very careful. Again, all over 3x plus 2 all squared. And then cleaning this up, 6x cancels with 6x, positive 4 minus 9, it's going to be negative 5 over 3x plus 2 all squared, which is going to be right here, option D. And so just be really careful tomorrow. Question 4 tomorrow, so the question having to do with the quotient rule, again, you're going to see that it's question 4 because these questions align pretty well. It's going to be the most difficult in terms of trying to clean it up and the most algebra involved, and so just be really careful with your step-by-step. Be very sincere with your annotations, and make sure you also then follow your annotations. Don't do what I did and accidentally not follow it and almost put the incorrect value there. All right, moving on, 2 left. If we take a look at number 5, we're being told this is f of x, which of the following equation is f prime of x. So again, we're just applying a power rule. Given a polynomial, applying a power rule, we're going to be told that f of x, well, it's going to have to be 3, bring this down, multiply it by the 4. It's 12x squared, reducing that power by 1, minus 5. Again, 3 becomes a 0. Anything with just an x is essentially the coefficient after you take the derivative. And then this sign, just remember that the signs always have to stay the same. So that negative is because of this negative up top. And so, taking a look, this matches answer D. There it is. And last but not least, problem number 6. Andre is training for a marathon where he's running a straight line along Central Ave. His position is given by the equation x of t is equal to 5t cubed plus 5, where x is meters and t is seconds. What is Andre's acceleration at t equals 4? Now, this is something that we did not put on our cheat sheet. And so if there is anything else you add, I highly recommend it be this. When we talk about position, x of t, we talked about this in class. I take the first derivative, x prime of t. When we take the derivative of position, we end up with velocity. And so x prime of t is actually the same exact thing as v of t. When I take the second derivative of position, x double prime of t, that's the same thing as taking the derivative of my velocity equation, which is acceleration. And so every time we look at how this changes, we move from position to velocity, and then velocity to acceleration. And so I need to know acceleration, which means I'm going to have to take the second derivative of this function right here, and then apply that t equals 4 after I have the actual function. And so let's start this off. X prime of t is equal to 15t squared. 5 disappears. All right, I have to do it again though. Don't get caught using this. Again, if we're thinking of distractor answers, odds are this is going to be there if you try and plug 4 in. And so x double prime of t, which remember is actually the acceleration at t time, is going to be equal to, well, again, it's just our power rule. Now, power rule is like the bread and butter here. It's going to be the thing we always come back to because it is just so often needed. Take this 2, multiply by that 15. It's going to be 30. T, 2 minus 1, that's 1. Don't really have to write it, but it's 30t to the first. And so now I have my acceleration. And so now I can actually find a of 4, which is going to be 30 times 4, which is equal to 120 meters per second squared. Now, important note here. Today in the practice test, we are given our units in all of our answers. Tomorrow, make sure you are really carefully matching units. And so remember that x of t, right, position is just meters, v of t is meters per second, and a of t is that meters per second squared. So whatever they ask you to find, make sure you have your units match up correctly. And so I'm looking for 120. These all have the same units. So I'm looking at B. All right. Feel free to go back at any point in this video, go see anything you need to see. Again, I highly recommend you put some form of this chart right here into onto your cheat sheet. If for whatever reason you lose yours, you can send me an email. I will try to have others ready Friday morning when I see you for your test. Otherwise, make sure you study. Just quickly look over that cheat sheet, look over your notes. See if there's anything you want to add. If you want to put an example, put an example. It is your cheat sheet to use as you want. Have a wonderful rest of your day, and I will see you all tomorrow for your test.